大家好，我是翔宇科技 Product Manager Hans，感谢各位光通讯业界先进参加这次 VIAVI HSE 和翔宇科技所主办的线上研讨会。那翔宇科技作为 VIAVI HSE 在海外唯一依赖 partner， 经营光通讯和储存领域非常多年，在业界受诸多客户的极高的评价。那今天很高兴能邀请我们的专家 Paul 跟 Thomas 两位在光通讯领域的专家，跟各位分享一下 800G 以及未来 1.6T 的趋势，在发展过程中会遇到的一些问题和挑战。Okay, let me introduce Paul Brooks. Now he is VIAVI Solution High Technology Marketing and Development Expert. Paul.
Good morning. Thank you very much. My name is Paul Brooks, and I'm part of the VIAVI team presenting today. I'm a subject matter expert on high-speed emerging technologies. This includes Ethernet, OIF, and Ethernet Alliance membership. We're particularly interested in high-speed SerDes, and I'll be presenting today for the introduction into 800 gig technology trends. Thank you, Hans.
Okay. And next one is Thomas Schroeder. He is our expert of Ethernet test solution for networking equipment manufacturer, and he's responsible for our new product line called HSE 800. Thomas, please.
Thank you, Hans, and good morning to all the people outside here. I see a lot of people joining. And next to Paul, I will present our really new product, which is even still not launched yet, but you will get a very nice sneak preview on the new HSE and what we want to deliver for you and what it brings you as an advantage against other tools you probably use, and how it fits also into our overall offering of layer 1 to layer 3 test solutions at the end. Thank you, Hans.
Okay. 接下来我们会正式进入研讨会的主题。那稍后会有问卷的部分，再请各位会后的记得填写。谢谢。Okay, Paul, you can start your slide.
Okay, thank you very much. I'll just now prepare to share my slides. I'll just give it a few minutes, a few seconds to load, and then we'll start. So again, thank you very much for joining us at VIAVI this morning. And I hope in the first part of the presentation, I can give you a background into some of the drivers to pushing 800 gig technology today and some of the technology trends that underline this. So there are a large number of market drivers for ever-growing Ethernet speeds. So some of the key drivers today we see active for the 800 gig ecosystem include transport and AI bandwidth. That demand continues to grow. We have multi-technology cycle waves of 100 gig, 400 gig, and 800 gig, all happening together, all depending on different use cases and applications. Data center fabric and AI I/O bandwidth are key speed drivers for the premium speeds today. There are millions of 400 gig ports already deployed, offering reaches up to 80 kilometers with ZR optics. So 400 gig ports are already shipping in huge numbers and a very established technology today. There continues to be standards development in photonics, DSP and ASICs, backed up by industry standards and MSA. Indeed, today, I'm here in California working in the OIF, where we're looking at some of the underpinning technology that can take us even further. That would include technology like 200 gig SerDes. That moves on to the new technology areas like 200 gig SerDes, new form factors that enable the client rates to move to 1.6 and even 3.2 terabit to support the industry roadmap to 100 terabit switch silicon. Switch silicon is one of the key drivers for raw bandwidth today. So even though applications like AI are playing a bigger and bigger part, today it's really switch silicon is driving the design, the density, and the bandwidth. And the relevant advance of the switch silicon bandwidth can be mapped out here. We're seeing over the past 12 years, we've seen 7 generations of switched silicon, which has given an 80-fold increase. There's been 4 SerDes speeds. So today, the fastest SerDes speed is 100 gig. We've moved 56 gig PAM4, 28 gig and 10 gig. So the first 2 major speeds were based on NRZ signaling, and then we moved to 56 gig PAM4, and now today we're seeing the emergence of 112 gig PAM4 signaling as well. So a lot of technology demands in that, which we'll hear about later. And the switch radix has also gone up 8-fold in that period as well. So we've seen a 10x increase in SerDes speed, an 8-fold increase in radix. This means moving over the past couple of years, we really do need an 800 gig capable port. Yes, we can deliver that bandwidth of 25 terabits over 400 gig ports, but we waste a lot of density which the silicon is delivering us. So today there's a firmly need for 800 gig class ports, and soon in the future that will move to 1.6 and even 3.2 terabit to service the potential for 100 terabit class silicon. Underpinning that demand for 800 gig is the emergence of different form factors. So at 10 gig, the QSFP Plus served the need. At 100 gig, the QSFP28 using 28 gig SerDes. Then when we moved to the first generation of PAM4 at 56 gig, we used QSFP DD. And now today, with the emergence of 112 gig SerDes, we're seeing QSFP DD 800 products beginning to ship. So 800 gig today, we are seeing an awful lot of 800 gig activity today. There are many new challenges, and it really is still something very much in the R&D phase, but with independent market analysts, people like Light Counting predicting a huge growth of 800 gig from 23 onwards. Now is the time to start addressing these 800 gig challenges to be ready for that massive market ramp we expect through 23 onwards. So if we move into that, what are we going to be facing? Well, the biggest challenge to date with 800 gig is the 100 gig SerDes, the physical layer challenges delivered when we move up from a 56 gig to 100 gig SerDes. That impacts the signal integrity significantly. And areas where at 56 gig things work still with margin, at 100 gig, challenges like connector placement, PCB traces, vias, package loss, etc., they play or have a far greater impact than they did before. So 100 gig SerDes is something that people wanting to take advantage of this great 800 gig investment wave really must master. The validation of 800 gig interconnect devices, the pluggables, that includes optics, DAC, AEC, active electrical cable, all will play a part for 800 gig class products. And with the mix and different applications people want from their 800 gig class products, it's important that any 800 gig product you develop has to interoperate not just across vendors, but also across a different class of pluggables, including optics, DAC, AEC. There are 2 form factors today associated with 800 gig, the OSFP 800, the QSFP DD 800. They're the 2 leading form factors, whereas at 400 gig and below, the QSFP DD was more dominant. We're seeing now, through various reasons, at 800 gig, especially early on, the OSFP 800 is a more dominant form factor. But we expect, as the market matures, we will see more QSFP DD 800 gig products as well. Today, those optics are available. Today, they're typically delivering 2 by 400 gig, offering high density 400 gig in the same face payment bandwidth as 400 gigs delivered today. And they allow customers to scale to 800 gig in the future, 800 gig Ethernet. So today, people are shipping products based on OSFP 800 or QSFP DD 800 as 800 gig plugs, but they're typically delivering 2 by 400 gig and ready for 800 gig. Early evaluation of chips and systems is underway. People want to start getting to grips with those 100 gig SerDes and understand the challenges, not just the signal integrity, also the thermal challenges as well, and manufacturability all play a major part. With the modules at 800 gig, In fact, this really started at 400 gig. Modules have become far more complex. So module management, typically today using CMOS 5.x variants, that plays an important part also in any 800 gig product. Everything from a module upwards must have a CMOS interface to be controlled and managed and orchestrate that module. So really the big challenge today is integrating all these different technologies, these parts, especially around the 100 gig SerDes, and then bringing to market the first generation 800 gig switches, dealing with the signal integrity, the hardware, the firmware, debugging, and the turn-up. Now, VIAVI has been shipping 800 gig products technology since 2020. And recently we've just announced 800 gig Ethernet. Before then, we had products supporting 100 gig SerDes, dealing with the needs of unframed and everything up to 2 by 400 gig. So one of the important things people need to get to grips with as 800 gig Ethernet starts to emerge is what's the specification? Well, today, there's only one firm specification for 800 gig Ethernet. That's the 800 gig Ethernet Technology Consortium specification that builds upon the 400 gig IP widely available today. So the Ethernet Consortium, and there's a link there for you, has created a specification for 800 gig Ethernet based on 400 gig 802.3bs, the IEEE standard for 400 gig. It effectively runs 2 400 gig pipes in parallel with some minor changes to alignment markers to allow very efficient reuse of logic. So inside the ASICs or the FPGAs, the FEC, the transcoding, etc., can be efficiently reused to scale to 800 gig quickly. So current switch silicon, many of those parts can run 800 gig ETC with only minor adaptations to logic. It's important to note that 800 gig ETC is not an IEEE standard. It may or may not align with any emerging standards for 800 gig and 1.6 terabit being worked on today in the IEEE. Now, it's likely that the 802.3DF, which is 800 gig, 1.6 tera based on 100 gig signaling, will reuse a tremendous amount of that 800 gig ETC specification. And we at VIAVI make sure that our 800 gig ETC implementation can support that. But for 200 gig SerDes, it's likely that the ET specification would not be used because it would need, we expect that 200 gig SerDes will need a much stronger FEC. So it's important when we think about the 800 gig ecosystem, we really are talking about chips through interconnect to complete systems. And we at VIAVI with our ONT 800 family already have a tremendous experience in this. We've scaled from single port upwards at rates from 10 gigabit all the way up to 800 gigabit Ethernet today. This covers the needs for IC vendors, including PHY, switch, ASIC, network interface cards, and AI. Test and validate the performance of the PHY layer and above. We offer Ethernet interconnect, including support for DAC, AEC, optical modules, everything from a DAC cable through to ZR for long reach for data center interconnect. And that's useful during the development, validation, and production phase. Complete system coverage, so supporting the hardware turnup, firmware integration, down to nanosecond baselining of live networks. Because when we get to 800 gig, people want to make sure they can use that bandwidth usefully, and the timing resolution of stamping packets and measuring the latency through switch fabric and PHYs now comes down to fractions of a nanosecond to make sure everything's being used efficiently. So that's a short overview of where we are today regarding 800 gig. But it's important to note that 800 gig is an emerging technology, and to catch the major explosion in 800 gig deployment, which independent analysts believe will start happening this year and move on through till 2026, the product development needs to start now. And to be successful at 800 gig, you really need to encompass all the layers, but especially the PHY layer and mastering that 100 gig SerDes. I'd now like to hand over to my colleague Thomas, who'll go in a bit more to explain some of the other work we're doing towards helping high-speed Ethernet scale and supporting your development, validation, and test needs.
Thank you very much, Paul. That was a very impressive presentation. Let me share my screen here now. Okay, so what I want to present now is a little bit the test solutions we are offering for testing 800G. And most of you know already the mentioned ONT 800 series, which is our traditional layer 1 or layer 1.5 test solution, really focusing on the physical layer and the challenges which the signal integrity, FEC, etc. brings with them. And also, to start this, I want to give you a little bit a comparison of our current two major test tools we will offering. So as I said, on one hand side, we have the ONT 800 platform, which is our advanced physical layer testing solution, which is focused for sure on a low port count. So for example, on 800G, we are offering 1 to 4 ports. On 400G, we are offering up to 8 ports. But the big advantage of the ONT series is also that you don't have any need for additional hardware for the test execution. So many of you know our ONT series, which has an implemented display and where you can, with a touch screen, really configure the test configuration and then execute the test directly in the test device. As I said, the ONT series is focused on the physical layer testing, and usually our customers have the need when they are going further on into their development that they want to test either more ports, so they have the need for multi-port testing on a switch ASIC, for example, or they're integrating switch ASICs or switch boards into their solutions, starting with the ONT and the physical layer testing. But then, as I said, they want to use multiple ports, more than 4 or more than 8 ports, and then they also want to add additional layer 2, 3 testing capabilities. That means really Ethernet traffic generation and analysis. And that is something we will cover in future with our new product, which is the HSE platform. And in this case, it's the HSE 800, named after the highest speed we are offering per port. And this is 800G Ethernet. The big difference here is that you always need also an additional test setup tool, but let's say better as other test tools which we see on the market. We are offering here web-based test configuration, so you don't need to install specific software on your own IT equipment and can just use what you have and start a browser and then configure and execute the tests. Very important also in the differentiator to the ONT platform is in multi-user support. So usually an ONT is designed that one user is working with a tool, testing optics or testing specific ASICs on the physical layer. The HSE is really designed that multiple user can at the same time use the tool and doing different testing on one platform. So what is the HSE 800 in a nutshell? In general, it is for network equipment manufacturers, IC manufacturers, module vendors, or let's say ICPs, means also all the cloud service providers. And it is for people who are working on high-speed Ethernet projects up to 800G. And the HSE 800 provides here multi-port Ethernet performance validation and debugging for research and development, system verification, or even production line testing. It's providing high-speed traffic load testing, system delay performance testing, and switch fabric performance testing that accelerates development projects by providing insights into lower layers, including PHY, PCS, and FEC stability. Unlike other tools, our HSE 800 provides a unique physical layer and Ethernet multi-flow functionality to generate alarms and errors, stress the FEC logic, and power integrity in one test system. And that's really the key differentiator to other tools, that you can have really the layer 1 up to layer 3 test solution in one system. And all of this ensures the ecosystem for interoperability, enables reliable performance, and also accelerate your product validation and helps you to get faster to market with your products. So why do you need the VIAVI HSE? And what are the key differentiators along with our market competition? So first of all, it supports the whole development cycle, from the integrated circuit through the component and system integration to the software implementation on top of this. Means, as I said before, it gives you full support of validation, the physical layer up to the layer 3. It has a flexible licensing of test ports through centralized license management per controller or even per license server, which sits in the cloud locally in your data center, or even hybrid solution that allows you also that the test solution grows with your need. It is independent on user IT infrastructure to an open web graphical user interface and Python test automation support. It has an advanced system architecture with independent controller chassis and a flexible connectivity to test module chassis. Means the controller and test module don't have to be in the same cabinet, and you can distribute, for example, a module chassis up to 10 meters next to the controller chassis. Means it can land in different cabinets and can be assigned to different teams. And the only, again, limitation is these 10-meter cable radius, because that is based on specific timing limitations we have here. And it's also a very small 19-inch form factor, not only compact in the high, which means it's a 1U controller and a 1.5U test module, but it's also very compact in the depths. It's smaller than 60 centimeters in the depths, and that's also a big advantage against our competition. So how looks the HSE 800 in detail? And we start with the hardware, which I said it's an 800G or 800G Ethernet speed. It is based on the 112 gig SerDes, which is currently the highest speed on SerDes lane. So it has integrated layer 1 features like the FAC. It is multi-user compatibility, and it is designed that we have these controller chassis, as I said, and it is in fact an own chassis, so you can disconnect this from the module, which sits below currently, and put it, for example, in top of the rack, and then you are distributing the module chassis along to different cabinets. The HSE controller, as I said, is a 1U 19-inch chassis, and it can connect up to 16 module chassis in a radius of 10 meters, which is a shielded twisted pair cable. It has a centralized licensing, so all the licensing is part of the controller. Can be advanced also then with licensed servers, as I said, which can be sit in the cloud, locally in your data center, or a hybrid solution. So it has a web GUI for the test configuration execution. It has Python automation and additional automation functionality. I will not go into details here now. Important also a precision timing to all of the connected module chassis, even based on an Iridium clock within the controller, or you can also use like a GNSS signal or an NTP time server. Then we have the HSE 800 module chassis, which is a 1.5U 19-inch separated chassis. The current module, which you're seeing here, has 8-port 800G, as I said, based on the 112G SerDes. It supports all Ethernet speeds from 50 gig to 800 gig, means it is 50 gig, 100 gig, 200 gig, 400 gig, and 800 gig Ethernet. It has full breakout capabilities. That means, for example, 8 port 100G per port, and that gives you the capability of 6400 gig ports in one single chassis. It has multi-user support, and when VIAVI talks about multi-user support for the HSE solution, it means really a single user per logical port. That means in general, if we have a breakout on one 800G port with 8 times 100G, that means that 8 users could work with one physical port. And through this flexible licensing, it is really a pay-as-you-grow solution. So as soon as you have more need for more ports, so for example, you are starting just with a 2-port solution, the hardware provides already 8 ports, but you only have to enable 2 ports per licensing. So you can start with a very, let's say, low price at the beginning, and as you need more ports, you can pay extra for more licensing. On top of the hardware, for sure, we have a specific software, and the coverage, as I said, is really the OC layer 1, 2, and 3 at the beginning. For further enhancements, we are also planning to add layer 4, 7 stateful traffic generation, but for the initial release, we are only looking for layer 1, 2, and 3. Means on the physical layer part and FAC part, we are supporting within the physical ports up to 25 watts currently. Means that is designed for supporting 800 gig ZR transceivers. We have a frequency offset and sending and receiving of plus minus 200 ppms. For sure, we have integrated the auto negotiation and link training, and then multiple metrics for the PCS layer, like TX FAC correctable, FAC uncorrectable, and so on. I don't want to read all of the different features here. You can see it on your own. Important is also that we have RX lane skew implemented at the beginning. On the layer 2, 3 side, again, we have different types of emulation here. We have the layer 2, layer 3 encapsulation with Ethernet type 2, IPv4, IPv6. So the traditional protocols, UDP, TCP, but as you know, this is mainly stateless for the traffic generation. As I said, a stateful version is planned for later on. We have layer 2, 3 emulation on ARP for IPv6. We have DHCP, ICMP, flow control, and also on the layer 2, the auto negotiation link training implementation, and then specific switch and routing emulation like ISIS, MPLS, RSVP, TE, MPLS, TP, and so on. Additionally, we also implementing benchmarking RFC test, like the RFC 2544 for network benchmarking, or the RFC 2889 for switch benchmarking, for example. All of this is designed to be very user-friendly, and we will see this in a quick GUI example, and I will provide the GUI example in 2 areas. First of all, a very quick glimpse on, let's say, a 4-step configuration. So you are starting with a physical layer configuration. Which kind of subtype and the speed do you want to use? For example, one single port 800G with 100G GAUI1. You need full PHY Ethernet standard implementation. As a second step, you are generating devices on the Ethernet ports. The third step is then creating specific protocol or traffic load profiles onto the devices. And with this, you have already created the configuration to start a test. And within the GUI, you will see a nice overview of the specific port application, which represents the configuration of devices and protocols on the specific port side. Means we have always a west and east side, which always, let's say, represents an port-to-port test, because we are focusing here always a port-to-port test means the traffic generation part and the traffic analysis part, which usually contains always minimum 2 ports. But let me go quickly into a more detailed GUI demo. I'm switching the display here. So what I want to show here is really the setup of a specific traffic profile and how easy it is with our new HSE implementation. So first of all, what we want to do is generate specific devices, and within this example, I will generate 10 devices which are simulating at the end the users which would be part of the network which you connect to the switch. Means the HSE really emulates or simulates the real world scenario you would see behind a switch within your customer base. So let me generate these devices, and then I need to change this here. So we have generated now the 10 devices, which are already multiplied by specific Ethernet addresses. So you see in general, as we had 4 ports in the test setup, which we have not seen here. I switched directly to the port generation. So we have 10 devices per port. That means we have overall 40 devices directly generated with a wizard. So next step is that we need to go into the device communication and into the Ethernet emulation. So we see we are setting up the IP addresses, the MAC addresses, and automatically we have let's say a differentiation that we are counting up the MAC addresses, that we have really independent distribution of the MAC addresses on the sender and receiver side. So we have Ethernet as our emulation, and then we need to add specific layers. So I go into the add layer and sublayer, or add layer and sublayer function. And in this case, I'm adding an IPv4 stack, and additionally I will add also an UDP stack on top of the IP, and then we can finalize this traffic with the VIAVI traffic profile. That means within the VIAVI traffic profile, we are adding informations like a packet counter. We are adding specific timing information. That's really the information we need to do delay measurement, which we need to understand if packets are coming in the wrong order. So a traditional, let's say, test layer, which provides information on top of the UDP part. Within a traffic profile, we cannot only create one so-called data plane stack, so we can add additional stacks on top of this. So I can I again use IPv4. So you see the IPv4 frame here gets a little bit bigger, but on top of the second stack, I will add a TCP and again the VIAVI traffic profile layer, which again creates then a second data plane stack. And again, I can go further with this. So I click again on the Ethernet part, add another layer, in this case, for example, a PTP slave device, and then, for example, another could be, again, the VIAVI TPL without any kind of IP or TCP or UDP layer. finalizing this with an additional VLAN layer. Again, you can see we can just add up multiple parts, very simple. And we get again the VIAVI TPL and created an additional stack. And I can move on with these kind of creation of specific traffic profiles. And additionally to that, we can set specific modifiers. So for example, on the IP side or on the VLAN side, we can set modifiers that they count incremental the VLAN ID, or they count incremental the IP addresses in the different data plane stacks to create hundreds or thousands or millions of different flows pretty easily on clicking these traffic profiles together. Let me go back to the presentation. It's wrong. Finally, I wanted to show what's the roadmap for the HSE. As I said, you have the privilege that we can show you already the system very early. So currently the plan is for this calendar year to release the HSE in November. In Q4 of this calendar year, we are coming out with the first release, which is the HSE controller, which is the HSE 800 test module with speeds of 400G and 800G. And we will have basic layer 1 support, basic layer 2 support, and then basic RFC support in the first release. But unfortunately, we can only limit this to specific customers. But also again, because you have the you can see the HSE already today, and if you work with the EagleTech team, we can make it happen that you will be one of the first customers to demo and proof of concept our HSE later this year, that you can have access to this as one of our VIP customers. In Q1 2024, we will add the release 2, which adds some more speeds like 100G. We will have enhanced layer 1 capabilities, enhanced layer 2 capabilities, and enhanced RFC capabilities, and then will be also available for all of our customers. And then follow on, the last release we are currently planning in this cycle will be the release 3, which will add all the 5 speeds, means 50G to 800G, and then we'll give you full capabilities on advanced layer 1, the full layer 2 capabilities, and adds first routing protocols. And you have then the full advanced RFC testing like the 2544, 2889, and so on. And that was mainly my part here. So Hans, do we want to open the audience for a question and answer round?
Yes. Allow me to speak Chinese. 各位好，那上面应该会看到一个举手和 Q&A 啊，麻烦你各位有问题了，可以先举手，然后在 Q&A 留下问题。我们这边会收到问题之后转发给 speaker， 让 speaker 回答。谢谢。Okay, Thomas, we received questions here. Number one question is, does it support NRZ at 25G and 10G speed?
So it will support NRZ 100G, but not NRZ 25G, right? So NRZ on 100G is supported.
Okay. Next question is, will this product launch in this year? People can receive the unit?
Yes. So as I said, the release is in November. So we are also planning to have, for example, a demo and proof of concept available before November. As soon as the demo or the POC has then finalized and the customer decides to order the device, then it's also possible to ship this year.
Okay. The third question is, what's the difference between ONT product and HSE product?
Yeah.
What's the major difference?
That's a very good question because we get this very often, and I tried to explain it already before. The biggest difference is really that the ONT at the moment and also for the initial releases of HSE will offer more advanced layer 1 features like dynamic skew analysis and different others. And also the ONT has a lower port count. And because the ONT is really designed to do physical layer testing and to do doing optical transceiver testing or transceiver testing in general. And the HSE is really something which is designed for multi-port testing, means switch testing. You can for sure also test transceivers or single port or ASICs or ICs with the HSE, but also the HSE only supports QSFP DD800 at this point. So that's the traditional interface for switch vendors. And the HSE also will not provide these advanced layer 1 features, because usually the switch NEMs or the switch ASIC vendors don't need the full layer 1 features at the test level, and that is really the key differentiators between ONT and HSE. So ONT, early stage hardware development, very deep layer 1 analysis functionalities, and then only for low port counts. And then you are moving, as soon as you are reaching the development status that you're going more into functional testing or even software testing, then the HSE comes in place with multiple ports, and then also the full layer 2, 3 capabilities.
Thanks,
but
Thomas.
still with let's say enhanced layer 1 features, but not the full set what the ONT provides.
Okay, thank you, Thomas. Next question. What's the modulation at 200 gig SerDes? Still PON4 or PON6 or even PON8? And next question. What's the most common high-speed I/O at 800 gig? Is it QSFP DD800 or OSP 800?
So perhaps I could answer
Yeah.
that. Might be easier. So thanks. There's two good questions there. Regarding the work being done today at 200 gig electrical, so VIAVI are very involved with that. And it seems that consensus is building to rounds using PAM4 modulation. Other ones were considered, including PAM6 and PAM8, as the questioner mentioned. The problem is, though, that this puts tremendous pressure on the design of the ADC inside the DSP for the SerDes and really hammers the noise margin. So today, the consensus is to use PAM4 signaling at the 200 gig rate. Now, regarding the 800 gig form factor, during the presentation, I mentioned early on, we see the OSFP 800 as being more favored, naturally biased towards people today who are deploying 800 gig early on the life cycle. But as it matures, and remember, it's going to, the independent analysts show the biggest ramp up is ahead of us. So starting 23 onwards 27, we will see a tremendous ramp in 800 gig, and that'll be more biased towards the QSFP DD800. But the good thing is, for the VIAVI product in the ONT family, we can support both today. So you don't need to worry about which one to bet on, because that's taken care of by VIAVI for you.
And I think to add to this, Paul, thanks for this, because you are really the expert on that. QSFP DD800 is really more the form factor which are used from the switch vendors. That's it correct, right? And as we are let's say, targeting the HSE traditional for the switch vendors, we decided to start with QSFP DD800, but that doesn't mean that we will never have an HSE 800 with OSFP 800 as well. So, but QSFP DD800 is definitely the interface of choice for the majority of switch vendors which we are targeting here.
Okay, next question. In the market, most bird tester can test simple error with PRVS signal. What's the difference between VIAVI and other vendors?
I think that's
Shall
a
I
good
take
question
that?
for you, right? Yeah.
Yeah, okay, thanks. Yes, that's a very good question. So I think the very important thing to note is when we move to PAM4 modulation, we now always see errors. There's always a background error flaw in the link now, and whether that's 10 to the minus 8 or 10 to the minus 14. What becomes critical isn't so much I'm counting errors, I'm seeing errors. What's the error fingerprint? Because that's the interaction with the error type and the FEC. And we at VIAVI have a wide range of tools that are designed to zoom in that, understand that it's not the PR, it's not the actual BR that matters, it's the profile, the error fingerprint. And that's really illustrated in the case of things like the FEC errored code words. Looking at the profile of that, the errored symbols in the code word, you get a lot more insight into the nature of the errors in your system than you will by looking at a raw BR. And that's becoming increasingly important because you can have systems that can run with quite a comfortable BR rate, and they seemingly are quite good, but ever so often they'll throw or drop packets and they'll give you link flaps. And that's something that isn't visible with very basic PRBS bit error rate testers, but is very visible with some of our VIAVI unique tools. You can quickly identify the error flaw isn't really an error flaw. There's some systemic problems in there. Could be timing, bit slips, error bursts, etc. And it's the tools we have that bring that out very quickly. With conventional unframed BERTs, you will basically just count errors and they won't give you any insight into the fingerprint and ability to fix the root cause.
Thanks, Paul. Next question. Does HSE support traffic transmission by DAC? If yes, what's this longest supported cable?
So we cannot, let's say, give a clear answer here now because currently we only have some cables under test. So DAC will be supported definitely, but we cannot say anything about the, let's say, maximum lengths. Currently, we are going up to 2 meters, but again, that is definitely not the end, but it needs to be validated first.
Next question. Does this support breakout mode for port configuration? Is there any configuration limitation of it? For example, the port number limitation.
So there is no limitation, and maybe I don't understand exactly the question. Because on the breakout, we are supporting with the HSE everything which is standardized, right? Paul, I think that's correct, right?
That's correct. Yes, that's right. And we have a lot of experience already on breakout applications, and that includes both the breakout of Ethernet rates. That's, for example, a good example today would be our ability to deliver through an 800 gig plug, like a QSFP DD800. We can deliver that as 1 800 gig, 2 400 gig, all the way up to 8 by 100 gig ports. And each of those, can be configured. You can alter the bit rates, you can alter even the phase relationship in lanes. These are all features we've got experience of today, and we'll be carrying that knowledge over and that experience over into making sure the HSE can address that as well.
It's really the limitation based on the QSFP DD800 interface specifications. So, and we are not having any additional limits on that.
Next question. What's your idea about 1.6 terabit, including form factor like OSFP XD or COBOL or CPL. What's your idea about new machine will develop in 1.6 terabit?
Yeah, so we can say that this will be the next product. So we will start with HSE 800, and the next product will be 1.6 terabit based on OSFP XD.
Yeah, I think it's important to make the note that this isn't a battle between OSFP XD versus co-packaged or COBO. Co-packaged has a very special place for some applications, but with co-packaged optics, you're dealing with a homogeneous interface without the pay-as-you-grow, without the range of optical PMDs. A plug, like today, we offer the QSFP DD800 OSFP, and like OSFP XD will offer scaling to 1.6 and 3.2 tera. The end user can scale the type of interface they want, copper, AEC, photonic, and the rate at which those interfaces are added. Whereas a co-packaged solution or a COBO solution is very good for scale right at the get-go and probably will have applications in supercompute, but it's not a battle between co-packaged and OSFP XD, for example. Pluggable optics will remain, and the flexibility they offer us in test and measurement solutions allows you to address a very, very wide range of interfaces. And remember, even if your target device has co-packaged optics, they will be pluggable optics that can interface to that. So there will be an interconnectability at the test solution interface.
Yeah, before the question on the timeline comes, I mean, currently the OSFP XD interfaces, for example, are not available yet, right? So as soon as they're available, which are, I think, forecasted for some time this year, we are starting to get deeper in our development. So, but we cannot say anything to the timeline, but we can say that after the HSE 800, you will see the HSE 1600, which will be OSFP XD.